Welcome back to Geometry. We are at section 10.7, areas of circles, sectors, and segments. The two new words, the two new terms that we have are sectors and segments. Area of circles we've done in the past. You've been doing this for a really long time, so this isn't anything new, but sectors is a new term as well as segments. So these are the two new terms that we want to focus on today. The first term that we have is sector. It's the region bounded by two radii and an arc, and it's a section of the area of the circle. So as usual, let's get a visual so we understand what a sector is. In a sense, a sector is really a piece of the pie, and if you think of this entire circle being our pie, you might want to eat a piece of it. And so if we were to say this is a 90-degree angle, that means this measure of the arc is also 90 degrees. But let's say that I wanted to find the area of this entire piece of pie that I'm going to eat. Well, since we have a 90-degree angle, we know this is going to be 1/4 of the total area of our circle. And if we were told that we had a radius of, let's say, 4 and 4, then we could take pi r squared, that's how we find the area of a circle, and we would get 16 pi times 1/4, and we would get 4 pi. And so the area of this sector would be 4 pi. So let's get that down for formulas. For the area of a circle, we have area is equal to pi r squared. And then area of a sector means that we're going to take our measure of arc AB, which will be in degrees, okay, and we just pulled AB. We're just going to say that this is A and B, okay, so the measure of arc AB, which was 90 degrees, over 360 degrees, times pi r squared, which is the area of a circle. Okay, and so that's what we did up here. This is very similar to the formula that we use to find the length of an arc. Okay, so last section in 10.6, we took this same formula but multiplied it by 2 pi r. Okay, now we're dealing with area, so we're going to multiply it by pi r squared. All right, find the area of the following sectors. So they want to find the area of this piece of pie, all of this area. We have 100 degrees measure for the arc, so 100 over 360. We're going to multiply that by pi r squared, and that would give me 5/18 times 36 pi. That reduces to 2 and 1, and we end up getting 10 pi, and we'll call it meters squared. Alright, so that would be the area of this little slice. And that makes sense because the area of the total circle was 36 pi, so it makes sense that this piece of the pie would be about 10 pi. Alright, next we have a circle has a diameter of 10. So let's show that with 2 5s. And what is the circle of an arc bounded by a 208-degree angle? Now, we've never really looked at an angle that's greater than 180. We know there's 180 degrees in this semicircle and 180 down here. Let's draw a 28-degree angle. Okay, so this is going to be 28 degrees. And so we add up 28 and 180, and so this total amount in red all the way across is going to be a 208-degree major arc. So just like last problem, we're going to take 208 over 360. We're going to multiply that by pi r squared, and 208 over 360 times 25 pi. When we reduce that, we end up getting 14.4 pi and then centimeters squared. Now, one thing that I just learned is that I'm not following directions that well. It says round your answer to the nearest whole number. I guess we're just going to give our answers in exact. Okay, but if you were to round your answer to the nearest whole number, you would just take 10 times 3.14 you would get 31.4, and so that would be 31 meters squared. All right, but we'll just go ahead and pretend like it said exact answers, not round your answers. All right, and then to the pizza problem. All right, we have a 14-inch diameter pizza. We'll show that like such. And then we're going to find the area of this pizza and subtract it from the area of a 12-inch diameter pizza. So area is going to equal pi times 7 squared minus pi times 6 squared. We end up getting 49 pi minus 36 pi, which gives us 13 pi, which if we were to multiply that out, we get 40.8 inches squared, and that would be how much more pizza we get from a 14-inch diameter versus a 12-inch diameter. Now, one thing that jumps out at us is this seems like a lot of pizza. I mean, this would be 3+ feet of extra pizza, but it doesn't really come out to that, because remember, it's just going to be a sliver. It's like a tiny little sliver more that you get. So if we put this 12-inch circle inside our 14-inch circle, this would be the pizza that you get more. And even though, you know, it seems like a lot of pizza, it's going to be a very narrow but 3 feet worth of pizza, but like really narrow. To like one bite would probably take up maybe 6 inches, so it's not as much pizza as it appears. All right, moving down below, our next new term is segment. So up above we had sector, and now we turn to a new term, and it's called segment. And a segment says that it's part of a circle bounded by an arc and the line joining the endpoints of the arc. So that's a pretty long definition. Let's get a visual. It's actually caused by a chord. So here's A, and then remember that chord has 2 endpoints on the circle. Okay, and so a segment is going to be the area that's right in here. So this amount in pink right here, this is what our segment is. So we're going to try and find the area of this. Now, we still have our sector, so if we start with our sector, and let's say that we draw one radius and a second radius, okay, we still have our sector, which would be the whole piece of the pie, okay, but what really happens here is our segment is going to be the area of our sector, which is our whole slice of pie, minus the area of our triangle, okay, because if we find the area of our sector and then subtract it from the area of the triangle, what we're left with is this amount in pink, which is our segment. So for all these problems, we're going to use this formula. So again, let's highlight this in red. This is our segment, which is what we're trying to find. So I'm going to put that the area, I'm going to put SEG, which stands for segment, is going to equal the area of our sector, SECTOR, minus the area of our triangle. Alright, so the area of our sector is easy. We have a 90 degree over 360 times pi r squared. We get 1/4 times 9 pi, and we get 9/4 pi. Alright, we're going to subtract that from 1/2 base times height, which is the area of a triangle. So we get 1/2. Our base is 3. Our height is also 3. Now, what allowed me to put 3 as the height is we know that these two lengths are radii. So since I put 3 here, I can move 3 here. So 1/2 times 3 times 3. And then that gives me 9/2. Now they want us in exact form, so we have to leave it just like this. We're going to put centimeters squared. Alright, next, again, we're trying to find the area of this segment, this little piece right here. So again, we're going to find the area of the sector, which would be 60 over 360 times pi 12 squared. 1/6 times 144 pi. and that will reduce to 24 pi. Okay, so again, we found the area of the entire slice of pie, this whole amount. But now we have to subtract that from the area of our triangle, and then that'll give us our segment, which is left over. So 1/2 and then base times height. Now for this triangle, let's redraw it out, and let's take a look at what we have here. Since this is a radius, this must also be a radius. We can put 12 and 12. We're told 60 degrees. Since these two sides are the same, these two angles are the same, we have an equilateral triangle. Alright, so this helps us out. We know the base of this triangle is 12. What we don't know is our height. So we're going to draw in our own height, and we'll do this with a dotted line. 90 degrees, 60, this becomes a 30-degree angle. If this whole base is 12, this becomes 6 and 6. 6 is our short leg, it's opposite 30 degrees. So we're going to use the rules of a 30, 60, 90 triangle. If the short leg is 6, our long leg, opposite 60 degrees, is our height, it would be 6 rad 3. Okay, so our height is 6 rad 3, and I enter that in here. Alright, from there, we want exact answers, so we get minus 1/2 times 12 is 6, 6 times 6 is 36, we get rad 3, that's exact, and we leave it in inches squared. Alright, next we're going to highlight this. This is our segment. This is the area that we're trying to find. The other thing that we should do is, since we have a 60-degree angle here, we want to deal with our triangle, and so this has to be 120 degrees. Let's redraw our triangle. If this is 120 degrees, and again, we're told that our diameter is 8 feet, so that means this is 4, this radius is 4, and this radius is 4. We have 4 and 4. And since these two sides are the same, these two angles must be the same, so that means we have a 30 degree and a 30 degree. Alright, and we're going to draw down our own height. We're going to create a 90-degree angle here and here. You have a 30, 90, this becomes a 60-degree angle and a 60-degree angle. So we're starting with our hypotenuse. To move to our short leg, which is our height, we take half of that, which would be 2. So h is going to be 2. That's the height. And then to move from short leg to long leg, which is half our base, it would be 2 rad 3. Now, remember that we just found this base to be 2 rad 3. This base is also going to be 2 rad 3. So the area of our triangle is going to be 1/2. Our base is 2 rad 3 plus 2 rad 3, which is 4 rad 3, and our height is going to be 2. Alright, then we still need to find the area of our sector, so the whole piece of pie, which was 120 over 360 times pi 4 squared. 1/3 times 16 pi, we get 16/3 pi, minus half of 4 is 2, that would be 4 rad 3 feet squared. Okay, let's hit up the algebra review as well. We have 2a to the third minus 8a. These share a 2a. We get a squared minus 4. This is going to then factor more. A squared minus 4, a plus 2, a minus 2. All over 4a squared. And we can reduce this down. This becomes 1 and 2. A goes away with the squared. So we have a plus 2, a minus 2, all over 2a. I can't cross these out because it's implied that we have to FOIL this first before I can cross anything out. So we have to leave it as such. This is our answer. It's reduced. Alright, problem 2. Let's change the pen color. We have x plus 8 times x minus 1 over x times x minus 1. X minus 1's cross out. We're left with x plus 8 over x. And we actually can't cross the x's out. The reason why is, let's say x was 10. Well, if we had 10 plus 8 over 10, your answer is 18 over 10. And we can't just cross out the 10s and say that the answer is 8. That's incorrect. So because it's adding, it's implied that we have to add first. This can't reduce anymore. We're finished. Problem 3, anytime we factor with a negative p squared, it can be done, but look at the problem that we will have. It's going to be 4 plus p, 4 minus p. And when I factor, I always like to have p be first and p be positive, or x be positive. So I'm going to rewrite this as negative p squared plus 16. I'm going to pull out a negative 1 in front, and this becomes p squared minus 16. If you look at what I just did, just times negative 1 all the way through, and we're right back to negative p squared plus 16. The reason why I did this is now I can factor, this becomes p plus 4, p minus 4. Alright, then all over, and then this is going to be p plus 4, p minus 1. P plus 4 is cross out. We're left with negative 1 in front, p minus 4 over p minus 1. Nothing else can reduce. Alright, then last one, we have x plus 2, x minus 2. And then that's going to be all over x plus 2 times x plus 2. The x plus 2's cross out. The answer is x minus 2 over x plus 2. Again, we can't cross out the x's. There's our answer. Thanks for joining us. See you next time.